You make a bunch of noise out here, so they have peace and quiet in here. Because there's no better sound than the squeak-free guarantee from Advantech Subflooring and Advantech Subfloor Adhesive.
Welcome to the UnBuild It podcast. I'm your host, Pete Yost, and I got my good buddies here, Steve Basic and Jake Bruton.
Howdy.
Hello, boy.
So we got a couple of great questions from our followers, our, what do we call them?
Listeners?
Listeners.
We're up to like 2.2 million.
Wow. There's that many people that listen to us? That's a little frightening. First one's from Brody.
They come to hear the jokes.
And his question's pretty straight, right to the point.
Wait, there's jokes?
Can I get the team's thoughts, not their jokes, on SIPs, structurally insulated panels, and are they advisable in cold climates? This is Brody asking this question. So what do you think, guys?
What are sips?
It's when you
We
just
should start
take little amounts.
They're small drinks. They're really small drinks.
Here, I'll illustrate.
I can't believe
For those
you
of you
pulled
that are
out.
just listening,
That
Steve
was a
took a
little more
very
than a
small
sip.
drink.
Structurally insulated panels.
Okay.
So that means we've got two layers of generally OSB as a structural sheathing, and there's a core of some type of rigid insulation. And the strength of the panel comes with it's a stress skin panel, which means the adhesion of both of the panels to the foam core are what give the strength to the panel.
What was that term?
Stress skin?
He's my favorite magician.
Stress skin is a magician.
Sounds like a magician's name. I've not heard that term before.
Oh, interesting. So, a lot of structural implications about how different it is to work with SIP panels and regular framing, which we might want to talk about a little bit, but that's not what Brody's question is.
Well, let's talk about that first. Like, let's continue our definition of what sips are first, because his question's
Yeah, okay.
simple on some level, but like, okay, so what insulations are on the inside?
If you glue up the panels, then you can use, most commonly, expanded polystyrene. You can use other rigid panels, but I'm trying to think of one now.
I've never seen one other than EPS that is the glued. The other one is an injected.
Well, so winter panel, which
Yeah,
we'll come to this resource in a minute. I notice I said resource. I'm working on that. Steve and I, back in 2004 maybe, wrote a detailed construction manual. Steve did all the drawing. I did all the text for winter panel, and it's like 90 pages or something. All the details you need to do to get SIP panels done correctly. And of course,
Winter panels a manufacturer.
They're in Brattleboro.
Yeah, and Amos Winter was the guy who opened the company, and he had two
He had
systems.
famous cookies, too.
Also
He
sounds
had
like he was
glue-up
born
panels.
in 1750, Amos Winter.
But he also had panels where he laid down one sheet of OSB and then put down a slurry of polyurethane that expanded to then meet another panel. Really a slick, complicated process, but pretty complicated, but you got a much higher R value per inch with those panels. I don't think there's anybody who does
Anything other than
the glue up panels. Now, stress skin panels, the strength comes from the outside panels and how they're adhered to the center. So actually drywall is a stress skin panel, and its strength comes from the adhesion of the two pieces of paper to the core, and it makes it way stronger than if you didn't have that bond of the two paper facings to the core. And what happens when you cut one face?
Yeah, it loses its
exactly.
integrity.
So it's all about how those two outside panels adhere to the core.
Composite action.
Ooh, composite action. So, Steve, what are the implications there in terms of both shear and then compression with a SIP panel compared to
Well, the minute you apply compression, it basically transfers to shear. I would think, right? Because like if you impose a load on that,
Yep.
then the panel itself it's trying to compress, but you might have differentiation in the EPS versus the panels trying to compress, so that the stress is being on that interface to want to shear and move.
So to give an example, if I were to cantilever that panel, right, and have bearing for the core and the
You are
inside,
going to love this, where this goes.
and I didn't have bearing on the outside, would I create a shear system there?
So I'm currently doing a project with SIPS panels,
Interesting.
and we're doing it on top of a concrete plank that's on top of ICF wall for a house. And one of the issues that I had was the exterior face of the concrete plank, I wanted to put rigid insulation on to warm it up, right? The band joist, basically.
Okay.
It's just a
Yep.
concrete band. And then we put the SIPS panel on there. The structural engineer immediately came back and said, I'm not comfortable not having the outer layer of the SIPS panel on the plank. It's on the rigid. Like, we need to get
Yep.
okay from the SIPS panel manufacturer. And they said, no, it needs to
It
be
needs to bear.
fully supported. So we're working
'Cause
out
the
that
system
detail
as a whole
to do
is
something. Yeah, we're working on the detail to do stuff, but yes, it needs to be supported.
Can I ask, leading towards this question, where is this house being built that you're working on?
It's
this?
being built in Alabama.
Okay, so it's not a cold climate.
No, but when he talks about cold climate, I was thinking most SIPS manufacturers I know are in cold
climate.
climates.
Yeah.
So can we define real quick, just in our mind, cold climate is 6 and above?
I'd say five.
Five and
is
above?
a
I'd
cold
say five and above.
Yeah.
Okay, I'm okay with that.
And that's probably like the northern half of the country.
Yeah,
Yeah.
It's
It
close
is.
to it.
I have a client actually that
Well, it's good. That's how you stay in business.
it is. It's true though. He does have
Do I need more
a
than one?
client. Yeah.
But not at your rates. Sorry.
Peter has a 200-hour minimum.
completely lost my train of thought now. The clients in the Pacific Northwest, it's as much about keeping the panels dry as it is how cold they get, but it is a cold climate. The other thing, the attraction of SIP panels to a lot of builders is that you can get your building built really fast. But if you think that it's important that structurally you design the building right, the installation of these panels is going to determine just how successful that system is.
So I'm going to test your dementia. When we were talking with who's
And your name again?
Yeah.
Yeah, Rose.
He's trying to.
Who was
figure out
the
who they were
guy at
talking
Winter
about.
Panel? I always forget his Dave Gothier.
Dave Gothier.
So I remember having conversations with Dave where he talked about building these. We were doing these micro houses, and they were going to use them as housing and stuff like in Arctic situations and stuff.
Yes.
So when people are talking about like, can you use this in cold climate? There's SIPS manufacturers out there that are thinking these are going to be used in Arctic, like, what's that, zone 7, 8, something like that.
Yeah.
Or worse. And they feel very comfortable designing for that. So I'm guessing 5 or 6 is probably not much of a challenge.
Well, and it's interesting that the manual that you and I wrote for Winter Panel, which is no longer in business, that was in Brattleboro.
Amos passed away.
That's
He was
climate,
162.
that's climate zone 6. So these are cold climates.
Yes.
So I encourage everyone, you can download for free the Winter Panel manual that Steve and I created. If you just type in Winter Panel guide, and it's funny, I was talking to Dave the other day, I said, why is this still available? It's like on this kind of random URL, Winter Panel's long gone, but somebody has preserved it that you can download it. And the reason Dave wanted Steve to do the drawings and for 3D Building Solutions to do the text was that he knew his panels were very moisture sensitive. So he wanted to have a way of telling his folks, this is the way you have to do it because these are more moisture sensitive. I mean, if you have a panel of OSB on the outside and a panel of B on the inside, you've built a diaper of sorts, right? Because they have low drying potential.
Yeah.
And then depending upon the thickness of the core and the type of rigid insulation, the moisture's not going to move through there very readily. So Dave, in that manual, said that if you did SIPS panels, you had to do a vented rain screen.
Right.
You had to have drying potential to the outside, so that at least that outside skin of the panel would dry to the exterior. He also said that on the interior, because the building was going to be inherently airtight, you had to use mechanical ventilation. Now, nowadays the codes have caught up to that, but back in 2004, it was pretty radical to say that if you use my enclosure system of SIP panels, you're going to need to make sure that you're not getting excessive humidity on the inside of the building.
I have some clients right now that we're about to break ground on a house for, and they've been, throughout their lives, they've been very forward thinking. In the late 90s, they lived in an earth contact house that they contracted themselves and designed themselves, and then in the 2007 range, they built a SIPS panel house north of Kansas City. And when they moved in, the first thing that they realized was that they needed ventilation because they had super high humidity levels immediately. And he was telling me that they had a independent inspector come and look at the house because they're getting ready to sell. And the guy was like, "What does this thing do?" And I was like, "It's 2025," and the independent inspector still had never seen an ERV in our market. And I was just like, "You got to be kidding me."
The other thing, I hate to tie this back to wing nut testing, but I'm going to, because after we wrote the manual, Steve, Dave became really concerned about the fact that the weakest part of the SIP systems is the joint. And so when you look at different SIP manufacturers, the real key is how do they create an airtight seal where every panel meets another panel? And Dave at Winter Panel had a keyed system, so there was a key built into every joint, and you drilled holes on the underside and injected spray foam until it came out the next hole. And that way you knew that you got it completely filled. But I had 2 or 3 projects sort of early on in my building science career where they were having moisture problems in SIPS roofs. And what we learned over several of these projects was that these panels are moving a little bit when they get wet and dry, cold and warm. And a hairline crack developed in the joints of the roof, and then more moist air got up in there, condensed, and ran down as water. So Dave said we need to add a detail for every panel joint
bridge
that has a backup air tightness plan. And that's when he decided he wanted to work with me on testing pressure-sensitive adhesive tapes, because he wanted the best tape he could possibly get to be the backup air seal of the panel joint. Because when those panels move back and forth and you crack that cured foam, the good thing about a good pressure-sensitive tape is that it'll maintain its adhesion as those panels move back and forth. And so he was going to go with either a 6-inch or a 9-inch really aggressive PSA tape as the backup plan for the panels.
Well, you bring up something that's like super important when we talk about both air and water leakage. It's never the center of a piece of a panel or a big sheet that's leaking. It's always the connection point. And when we look at SIPS panels, the connection point is the entire edge, the entire perimeter of every single panel.
Yep.
So those connection points become that much more critical in every single panel, because you're dealing with trying to get sometimes a 20-foot joint together and get it to line up, and then you're moving over 8 feet and trying to get another 20-foot joint to line up properly. And like that's one of the challenges, is you're trying to get 2 things to line up perfectly that are too heavy for a person to move, like you're having to use equipment. And so like there are some challenges, there is some nuance. I'm not saying that SIPs are necessarily wrong in any way. It's just when we start talking about air leakage or even the water management aspect of it, you're taking that connection point that like on a zip system where we just tape it with a piece of tape and we're over and done with. Now you're talking about this thing's really long, this thing's really heavy, this is a really challenged point that we have to make that connection. So
It's also interesting that, Dave required that the rain screen on the vertical panels for exterior walls be vented, but he required it for roofs too. So if you were doing standing seam metal on a SIP building, he said you're going to have airflow on the underside of that standing seam metal.
We've actually done that detail a couple of times.
Yeah. But I have a project to which this is relevant. The code.
So you have another client.
Could be the same one. He didn't.
He didn't specify.
The code says that WRBs must be vapor permeable. The code says nothing about what roofing underlayments vapor permeability has to be. I have a project where the SIP panels were used for the roof. Building's 15 years old. They used a vapor impermeable roofing underlayment with cedar breather and cedar shingles. The panels got wet and didn't dry because they used a vapor impermeable roofing underlayment. So there was no way for that moisture to get out of that system. So I don't know why we do that. We insist that you have to have a vapor open
Wall.
weather barrier on the wall, but not on the roof. And that's important. If you expect that top sheathing to dry upwards into a vented space like cedar breather, the only way that's going to happen is if you have a vapor open roofing underlayment.
That's because they only ask the question of how do I keep the water out?
Yeah, that's what I was getting ready to say. Because there's so many people still going, well, we don't want water to get in there.
Yeah. You know, it's interesting. So going back to the SIPS panel in a cold climate, when I think about it, the one we're doing it's a 6.5-inch panel, which yields 5.5 inches of EPS. So it's probably like R25-ish, right? 24 or something like that.
Very quickly, which we should point out is a continuous R25, which is
it is
great
continuous, which is
R value.
Very, very good.
Really aggressive.
But I'm trying to think, what's the biggest I've ever seen? I think they go up. The largest I've ever seen is maybe like 11.25-inch panel or something like that, where we've used them on roofs. So you're probably somewhere in R, say 20 to R high 40s. Let's say 48. So that's your range. The question is like, how cold of a cold climate is he asking? Mm-hmm. Right?
Yeah.
Because the other beauty, I think, of the SIPS panel is one of the things that it's a hard pill for me to swallow is installing all the utilities. I know they have solutions, but that's the tail wagging the dog, in my opinion. Yeah. Right? If I were to do a SIPS panel house, I think I would reduce the panel size to a smaller panel, save that money, and then frame a 2x4 wall on the inside of the exterior wall.
It's funny you say that, because when we did our SIPS edition, which was at 208 Fairview Street in Brattleboro, we did.
Way to give out an address.
Yeah, no kidding. Just because you don't live there anymore. Yeah. Hey, why don't you just come drive by, spray, paint on the wall.
I don't know where that came from. I don't know why I said it, but it was SIPS for the floor because it was on piers, the walls and the roof.
I did the drawings.
That's true. You did do the drawings.
And nobody's telling the listeners.
Oh,
not you.
He's telling the listeners. I thought he was telling.
He knows you know.
And Dave said, "Hey, you want me to chase this for the wiring?" And I said, "Why would I pay you good money for that insulation and then have you route it out?" So I did a baseboard raceway, and then I ran all the wiring through a framed wall. But this is a big issue with my current client because he said, "Well, we can get these routed out by the manufacturer." I thought, let's see if we can take a more creative approach to running it's only wiring that is the issue. Yeah. It's not any piping.
I mean, I think SIPS panels are good. I think their strength is in the fact that I get continuity, like Jay pointed out. I also probably get somewhat of speed to the construction schedule, because while we're pouring the foundation, somebody can be building my walls.
Yep.
Right. Yep. And then they come, they drop them on there. And I mean, on a 2,500 square foot ranch, I would expect it's probably 2 or 3 days of setting those panels at most.
At most. Yep.
Right. And so going to a smaller panel and then saying, hey, let's put a 2x4 on the inside. Yeah, it costs a little bit more money, but I'm saving some of that by not using the thicker panel. But I'm also making it easier for the plumber, the electrician, HVAC guy, all of that. And I can put a very
on the outside walls. Then
That's right.
and,
you could. Yeah.
and I
yeah.
can put a very inexpensive unfaced insulation in the cavity.
Yeah. Yep.
To work in my favor. So I think at the end of the day, you're pretty close to about the same.
That's really an interesting approach. I mean, because the raceways don't allow you to have ADA compliant height of the outlets, because you're doing it down in the baseboard. So that would solve a big problem if you just did it's like an interior partition, but it's flush to the outside of the building.
for those of you that don't know, the alternative to doing the raceway or having them chase it for you is superheating a lead ball bearing and dropping it through the cavity insulation and letting it all the way through.
Kidding.
Yeah, have you not seen this?
No.
Okay, so on the Build Show Network, Travis just did a video about them fishing
No
one.
kidding.
He has a SIPS project going right now in Kansas City.
That is really cool.
What a slow, horrible, crappy nightmare. It's just the worst. Like, anybody who says this is the way you should fish wires in a SIPS panel is an idiot.
Hey, I wanted to ask you this, because when we did that addition, Dave asked me if I wanted to buck the window openings or simply attach the windows to the outside OSB with a really aggressive screw. And I told him, I said, if you can tell me that I can get the windows installed properly, I don't want to put a wood buck in around the rough opening just for nailing, because I'm taking out, R6 per inch and putting in R1 per inch. What have you ever done?
Our detail has the buck all
Has
around
the
the
buck.
opening.
Yeah, and that's
I want
just
something to be able to, because we're using
Structure.
European Flanders windows.
yeah,
so
yeah,
we
yeah.
need to attach the bracket or a turbo screw. So I need something laterally to fasten.
Yeah, interesting.
So
Good.
We got another question?
Yes, we do. This is from Paul. And
hello, Paul.
love learning from you guys. I've changed many things in the way I build and look at buildings. I'm starting my own personal home, and I ordered Zip R12 sheeting. These are the Huber panels for my walls. Excited to use this project my first time. The concern I have is how much R value will I lose out of the polyiso foam? Huber says it will lose some, but doesn't say, at least to my knowledge, what it will be after 15 years. So my question is, if I have a 2-inch polyiso panel, what's the R value in 50 years?
How old's Paul? Is he going to still live there in 50 years?
Paul, we'd be happy to answer your question. We just need to know your life expectancy and if you have a life insurance policy.
I mean, there's probably not a building. I'm trying to think if there's a building material that doesn't degrade or lose something in 50 years.
So,
Not to defend.
Now, I'm not trying to defend it, but even glass, if IGUs are allowed to lose,
they are
upwards of like 10% or 1% per year, something like that,
Yes.
of their air seal, right?
Yeah. So I'm going to do a plug here for my former company, Building Green. They've got a really great insulation report. It's like 100 pages and addresses all aspects of different insulation performance, including this very issue. And so it depends on what the gas is inside the insulation. So
the blowing agent.
The blowing agent in expanded polystyrene, it's air, right? So the gas leaving and the gas coming in over time is the same gas. So the R value that it is now is the R value will be in 50 years. Any gas that's in there that's not air is going to leak out over time. And so, for example, polyiso panels, the blowing agent is pentane. And so when that pentane leaks out, whatever boost it was giving to the R value performance of the panel, because it's pentane rather than air, will be replaced. And so there's two issues. One of the issues is what's leaking out and what's its impact on the overall thermal transfer through those little tiny pockets. And then the second thing is, how fast will it move out? Well, how fast it moves out depends on a whole bunch of things, like what's the next thing that it communicates to, right? Because it's trying to move out, but if there's a lot of resistance at the face on both sides, that makes a big difference. The thickness makes a difference, right? Because the
Further entrapped it is.
the deeper it is inside that, like a 2-inch panel, it's got to make its way to the surface. So I don't know what the exact R value would be in 50 years, but the erosion of the R value over time is pretty bloody slow. To begin with, the polyiso panel starts off when it's manufactured at around R7, and the quote-unquote
Per
inch, the quote-unquote aged value is somewhere in the 6 to 6.2 range. So the manufacturers already have to account for that exchange. But that exchange rate is not linear. So you can't say, well, if it lost 0.7 R value in 2 years, it would lose 1.4 in 4 years, right? It's not a linear process because of that thickness and how it has to transfer through that depth. So I think that
So does it degrade faster at the beginning or?
Much faster at the beginning. Yeah.
And when you're saying it's losing pentane and replacing with air is also the insulator that we use. Like that's the thing that makes fiberglass an insulation, right? So like it's being replaced by something that's still an insulator.
Yeah.
So like there's an interesting thing that happens there from a science perspective that like air is not as good as pentane in that instance, but it is still insulated.
Yeah, and to go back to the window perspective on this too, you bump up the R value of the window by putting in a gas other than air, like argon or krypton or xenon. But the gas that you put in a window depends on the distance between the two panes. Like the best gas for a 1/2-inch gap is argon. If you make that gap less than a 1/2 inch, the heat transfer properties of the gas are different for different thicknesses of the space between the two. So like if you go to a 1/4 inch between the two panes of glass, now it's worth switching from argon, which is a lot less expensive than, say, xenon, right?
Okay.
Because the transfer properties of the gas in that space.
Where do you shop? I don't know if I've ever seen xenon
Just on the shelf.
windows.
Oh.
You know the thin glass triples windows that they have? Yeah, one of the reasons the patent for triple pane thin glass was pulled in like 1991, but the cost of xenon was really, really high. And the thin glass triple has a really thin pane of glass in the middle, but you have to make it in really big sheets. So that patent sort of lay dormant for almost 15 years, because when we started to do a lot of fracking, the capture of xenon gas went way up because it's part of that process. And the other thing is that we phased out outdoor fluorescence, and for outdoor lighting, one of the key gases for that type of light is xenon. Well, we now use LED outdoor lighting. So the demand for xenon went down, the supply went up, and now we could afford the xenon gas for the thin pane triple. But to make those cost effective, you have to have really big sheets of thin glass. Well, when did we start to make really big sheets of 1 millimeter glass? Flat screen TVs. Yeah. So in the mid 2010 to year 2020, we had a drop in the cost of the gas fill that's appropriate, and we started to make much more cost-effective thin panes of glass. So that's why the patent came around to be relevant. But we weren't supposed to be talking about windows right now, were we?
That's okay.
So to go back and make sure we answer Paul's question.
Yes, it's going to get worse.
Yes, it's going to get worse. I think there are way bigger things to worry about than the decrease in R value of your polyiso panels.
Agreed.
do we want to?
That was a great pause at the end of that.
That was
I like it.
That was a very cool conversation about insulation.
Very cool. Dude.
Do you have any thoughts?
Oh, I always have thoughts.
I'm so glad I don't have to look
we
inside
wrapping up thoughts?
your head. Yeah, we are.
So, I was thinking the other day, because we're down in Texas. Texas drinks Dr. Pepper. A lot of it.
Is that right?
Yeah.
Huh.
It's very beloved down here. You ever wonder what kind of doctor Dr. Pepper was?
Nope.
Was he salty?
I don't know. I think personally he was a physician.
That's good.
You heard it here first on the podcast. Steve's 10-second humor sliced.
Thank you, Peter.
Really good.
I wasn't expecting a spelling joke from it either.
I think he just wanted to
wordplay, I guess.
make fun of the way that I say resources.
I don't make fun of you ever. I only hold you in the highest of regard.
Not while he's here, at least.
Guys talk behind my back all the time. Thanks for suffering through yet another episode of the UnBuild It podcast. Jake, where do they submit the questions?
Questions at UnBuild It Podcast.
Steve?
Well, I was just
.com.
gonna. I'm gonna just throw a plug because we're on the build show now. So that house that we're doing with the SIPS panel, it's ICF foundation, indoor pool made out of ICF, concrete
Whoa.
plank floor. It has an apocalyptic bunker in the basement. That's like an apartment.
An apocalyptic bunker. Is that an architectural term?
Well, yeah, it's my joking term with the client. And then it's SIPS up above from there.
So we should collaborate.
With
I have a SIPS project going on.
Real stone. So anyways, all I'm saying is look forward to it because that series should start a little later this year. Probably about the time this podcast comes out.
What would be cool would be to compare your details for this project to the details you did for the winter panel manual, which was over 20 years ago now.
Yeah.
That would be cool. I bet you they're timeless.
I bet you they're pretty. It's
Because
a pretty.
you're a timeless kind of guy.
Well, and it's a pretty simple concept, SIPS panel. Like
And-
there's not a whole lot you're going to do to it, and like Jake said, you have to deal with the joints.
And did
So
you keep the
joint
basic
technology-
geometry of the building pretty simple to honor the panels?
No.
Okay.
The panel company's having some fun putting that all together. We have a large curtain wall out back, and
It's a monopoly house, right? It's flush. You're going to build. Are you building overhangs?
So it gets. We do have like a 30-inch overhangs.
The panels. The roof
No,
panel?
they're not
No.
panels. These get tied back into the panel.
Right, but you're doing a
But
flush
the
box
flush,
and then
it's a
add it.
flush box, and then these get added to the
A
outside.
30-inch add-on. That's going to be interesting.
It's going to be fun.
Yeah.
Glad it's not
Very
in my
cool.
market. I'm glad I'm not the one building it.
So
Thanks for listening. It's a wrap.
Have a good day.
bye.